Ladies and gentlemen, you're welcome to once again this discussion where we are looking at applications of partial differentiation. Partial differentiation. So we have an application that the dimensions of a cone are r, which is the radius, is equal to 25 millimeter, and the height is equal to 70 millimeters. Calculate the approximate increase in volume of the cone when the radius increases by 5 millimeters and height decreases by 10.5 millimeters. Here we are talking about use of partial differentiation to approximate the rates of change. So if I have a function f of x, maybe t, okay, and I say I'm looking for del f del x, I'm talking about rate of change of x with respect to x, of f with respect to x. If I talk about del f del t, I'm talking about the rate of change of f with respect to t. That's what I'm talking about. So here, this that they have brought before us, they want us to apply the partial differential equation and be able to understand that here, this rate of change, if it is positive, it is increasing. If the rate of change is decreasing, okay, if it is increasing, it is positive. The rate of change is positive if it is increasing. But if it is decreasing, then it will be negative. That's something that we must understand. But here we are talking about a cone, and a cone has a volume which is equal to pi r squared h divided by 3. So here we can see that this volume is a function of r and h. So if we are looking for the increase or the any change in volume, this is going to be so that sigma v, which is the change in volume, is always going to be del v del r, okay, the rate of change of this volume with respect to r, then times the change in r plus del v del h times the change in h, because h is the height. So if volume is changing with the height, and we know that rate, if we multiply it by the change in height, then we will be able to find that change in volume that has occurred as a result of change in height. Then if we have del v del r times the smaller change or the change in r, then it means what we are getting here is the value of the change in volume, okay, when there is a smaller change or when there is a change in radius. Having understood that, we move ahead and look at what we have. So we have to calculate the approximate increase in the volume of the cone. So our delta V, I mean our sigma V that we are having, or the change in volume, is a positive. Now, the increase in radius is 5 millimeters, meaning the change in radius is a positive. Height decreases, meaning the change in height is a negative. What we have to note is that sigma r is equal to 5 millimeters, sigma h is equal to negative 10.5 millimeters. That's what we are talking about. If h decreases, then this change in h is going to be a negative. But if it had increased, then we would be making it a positive. So what is del V del R? So when I look at this, if I look at the formula for calculating volume of a cone is pi r squared h divided by 3. If I look for the partial derivative of volume with respect to r, this is going to be keeping h a constant, and therefore I will have 2r times pi times h divided by 3. Usual differentiation that we know. So this becomes 2 pi r h divided by 3. Yes. Then what about del V del H? This is going to be if I differentiate partially, or if I take the partial derivative of volume with respect to H, then I'll keep the rest of the components or the rest of the parameters constant, then I vary H. So that means this is going to be pi r squared out of 3 only, because if I differentiate this V with respect to H, that's what I will get. So I come here and write pi r squared divided by 3. But I know r is equal to 25. I know h is equal to 70 millimeters. All are in millimeters. So what I do, I just substitute in this function or in that equation, sigma v will equal to, I know del v del r. Del v del r is 2 pi r. R I know it as 25, okay, times h, I know h as 70, divided by 3. Then plus, I need to multiply it by the change in r, which is 5. Then plus, del v del h. Del v del h is pi r squared, whereby r is 25. So 25 squared, okay, divided by 3 times del h. But this del h is negative, so negative 10.5. So what does that give us? So I'm going to be having, if I use my calculator, this is going to be what? I have 2 pi out of 3 times 25 times 70 times 5 plus pi times 25 squared times negative 10.5 divided by 3. So this becomes, if I evaluate this becomes 50 pi times 350 divided by 3. Then I take away 25 squared times negative 10.5 pi divided by 3. So I'm getting 25,198.19 cubic meters. So if we are talking about, it is cubic millimeters, please. It's cubic millimeters. So this is the increase. So if we are talking about the rate of increase, then this is going to be per second. If we talk about the rate of increase in volume per unit time, then this can be the one. So the increase in volume will equal to 25,198.19 cubic meters per second. And that's all.